Welcome back to the discussion and thank you for always joining us. This is K.c.s.e 2020 paper 2 question number 14, and the question we have reads: solve the equation sin squared theta minus cos squared theta is equal to negative half for the range of values of theta between 0 degrees and 360 degrees. The first thing we need to remember is that we are going to start by applying the first identity in trigonometry that states that if you take the sine squared of theta plus the cos squared of theta, this one will be able to give us 1. In this case, we can decide to make the sine squared theta the subject by moving cos squared theta to the other side of 1, such that the sine squared theta will be equivalent to 1 minus cos squared theta. In this case, now we can bring down the main equation, but anytime you see the sine squared theta, you place 1 minus cos squared theta. In this case, sine squared theta is the same as 1 minus cos squared theta, then plus we have, that is minus, we have minus cos squared theta, and this one is going to be equal to negative half. At this point, you realize minus cos squared theta minus cos squared theta will give us twice cos squared theta, and therefore this one will be 1 minus twice cos squared of theta, and this one is going to be equal to negative half, which is the same as negative 0.5. If we move 1 to the other side, we are going to remain with negative twice cos squared theta being equal to negative 0.5 minus 1, meaning negative twice cos squared theta will be equivalent to negative 1.5. Next, we are going to divide both sides by negative 2, such that negative 2 and negative 2 will cancel, giving us cos squared theta being equal to, if you take negative 1.5, you divide by negative 2, you are going to get an answer equivalent to 0.75. Once we have gotten that, this is cos squared theta, and therefore to get cos theta, we are going to take the square root of 0.75, and the square root of 0.75 will give us plus or minus 0.8660. Once we have done that, we are going to proceed by reading off the cos. So the first value of theta, let me call it theta 1, will be equal to the cos inverse of negative, that is, we start with positive 0.8660, and this one is going to be equivalent to positive 30 degrees. And also to get the other value of theta, let me call it theta 2, we are going to take the cos inverse of negative 0.8660, and this one is also going to give us negative 30 degrees. Once we have gotten that, we can now move direct to the unit circle. I'm going to use 2 unit circles. For theta is equal to 30 degrees, I'm going to come up with the unit circle. Let me simply sketch the unit circle by using the 4 quadrants this way, where we are going to have A, this is sine, this is tan, and this is cosine. We know all angles in the first quadrant are positive, and since this is cos is positive in the first quadrant, and therefore we are going to measure 30 degrees from the horizontal in the anti-clockwise direction. This is 0, this is 90, this is 180, this is 270, and of course 360. So for the first value of theta, we measure from 0, 30 degrees, and then the other value of theta will be, remember cos is also positive in the fourth quadrant, so we are going to measure 30 degrees from the horizontal in the clockwise direction. So to find the size of the angle that lies in the fourth quadrant, you are simply going to take 360 minus 30 degrees, or simply from 0 all the way to this point, we are going to have 330 degrees, or simply 360 minus 30 to get 330 degrees. Also, we can do the same for negative 30. We can draw again the unit circle as we have done up there. This is A, S, T, and C. That is for the cosine. So remember, this is cos theta, which is negative 30, and the cos is negative in the second quadrant. So we are going to measure 30 degrees from the horizontal in the clockwise direction, and again it is going to be negative in this quadrant, which is the third quadrant. So we are going again to measure 30 degrees in the anti-clockwise direction. So 30 degrees here, such that we are going to have the first value of theta. In the second quadrant, we are simply going to take 180 minus 30, giving us 150 degrees. And in the third quadrant, to get the theta, we simply take 180. We add the 30 degrees, giving us 210 degrees. Remember, this is 0, this is 90, this is 180, 270, and 360. In this case, the values of theta that are going to satisfy the given conditions will be 30 degrees. This one will be 30 degrees and 330, or we can as well use 150 degrees and 210 degrees as the answer to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.